All right, so in this problem, we had 200,000 visitors to the amusement park in 91, and 6 years later, 834,000. So assuming that this continues to grow at an uninhibited rate, we're asked to find the exponential function. Okay, so let's write down what we know. And what we know is when there were certain amounts, right? In 1991, there was 200,000. And in 1997, there was 834,000. Now, typically, what we do here is let our model start the first piece of data that is given. That is, we'll let t be 0, not 1991, when the amount or population is 200,000. And then 6 years later, it's 834. Okay, so I'm not using these large years for my input. I'm going to reset it when the first bit of data was given, which is 91. Okay, so my model looks something like this. Okay, maybe you've seen with A's as well. A of t equals A naught e to the kt. So we're given the initial amount, so that's good. So we have one of our parameters, 200,000, right? And remember, this is a variable and this is a variable, so they'll be part of our answer. So essentially what we need to do is find k, all right? And they've given us enough information to find k. So that is, we'll have to use this other data point. So at 834, we set that equal to, remember this 200,000, that's fixed. That's part of the function. That's always going to be there. And then I'm going to plug in the t that corresponds with the 834, right? That's 6. All I'm going to do is solve this equation and I'll have my value for k. So divide both sides by 200,000. Right, and I'll just kill all those zeros for now. So that gives me 834 over 200, which I could reduce, but I'm not going to at this moment, equals 6 times k. The next step's the big step. Take the natural log of both sides. Right, and the reason we do that because the natural log of e to the 6k is just 6k. And then again, I'm just going to leave this for now as 834 over 200, natural log of that. And then the last step to solve for k would be divide by 6. Okay, so that's k right here, the natural log of 834 over 200 divided by 6. If you plug that into your calculator, you should get a value of 0.2379. Okay, and then finally to answer the question, I'll have to write P of t equals, and then the initial value, which is still 200,000, e to the k 0.2379 variable t. So let me circle that since I ran out of room. That's the answer. That is the model that represents the data. If you graph that function, it'll go through the two given points, and it'll also give you all the other points that represent input time, output, number of people at the park. Okay, let's do one more of those. Something similar. Amount of carbon-14 remaining in animal bones after t years is given by A of t equals A naught times e to the negative 0.00012 t, where A naught is the amount present initially. Estimate to the nearest ratio the amount of age bone. The age of a bone containing 22% of carbon. Okay, so basically we're given the initial, we're given the function, right? We're given the growth rate. And that's all we really need, or I should say the decay rate. Okay, because if I want to know an age of a bone that has 22% of the initial amount, then here's the initial amount, here's 22% of the initial amount. Okay, so let's digest that for a second. If we had numbers in here, it might make a little more sense. That is, if I had like 1,000 here, what's 22% of 1,000? It'd be 220 over here. So similar to the last problem, it'd be 220 equals 1,000 e to the negative 0.0012t, and then I divide both sides by 1,000, and I get 0.22. Well, really, it's the same thing here, only it doesn't really matter what the initial amount is. We're just calling it the initial amount, and I'm going to set it to 22% of the initial amount and solve for t. So when I set it to 22% of the initial amount, that's what that looks like. 0.22, 22% is a decimal, times the initial amount. So we do the algebra here the same. Divide by that initial amount, whatever it is, doesn't matter, and you end up with this equation. Okay, and once I do that, I solve similar to what we did to the last one. I take the natural log of both sides. Right now, I'm not going to type that into my calculator yet. Take the natural log of e to the negative 0.0012t, just leaves me with the exponent. And then finally, they're asking when, so I'm solving for t, so I'm going to divide by the coefficient of t. Okay, and you see we have a negative number here, but that's okay because we have really two negative numbers, because the natural log of a number smaller than 1 will be negative. Okay, so you got a negative divided by a negative. You do that in your calculator, and you get somewhere around 12,618 years.